Hello and welcome. Across our planet, in every conceivable habitat, a silent, tireless workforce is in operation. These are not human engineers or architects, yet their creations rival our own in complexity and ingenuity. I'm talking, of course, about the animal kingdom. For millions of years, long before we laid our first stone, creatures great and small have been constructing extraordinary structures, driven by the fundamental instincts of survival, procreation, and protection. These are nature's master builders. From the vast, sun-scorched savannas to the hidden depths of the ocean, animals build homes that are perfectly adapted to their environments. These are not merely shelters. They are intricate systems designed for climate control, defense against predators, and the raising of young. The materials they use are sourced directly from the world around them: mud, sticks, silk, even their own bodies. The diversity of these structures is truly staggering, a testament to the endless creativity of evolution. In this journey, we will explore 10 of the most remarkable animal architects. We will witness their tireless efforts, their collaborative spirit, and the sheer genius embedded in their genetic blueprints. Join me as we delve into the world of these wild architects and discover the incredible homes they build, marvels of engineering hidden all around us, waiting to be appreciated. It is a story of resilience, innovation, and the profound connection between a living being and its home. Here, in the temperate forests of North America, a master engineer is at work. The beaver, its ambition is not to build a simple shelter, but to reshape the very landscape to suit its needs. Using its powerful incisors, it can fell a substantial tree in a matter of hours. These timbers, along with smaller branches, rocks, and mud, are the building blocks for its monumental creation, the dam. This structure, meticulously constructed, can stretch for hundreds of feet, transforming a flowing stream into a placid, deep pond. This newly formed pond is the beaver's fortress. It provides protection from land-based predators like wolves and bears, and allows for easy transport of food and building materials. Within this safe haven, the beaver constructs its lodge, a dome-shaped island home with an underwater entrance. The walls, plastered with mud and insulated with wood chips, are so robust that they freeze solid in winter, creating an impenetrable barrier against the cold and any creature that might try to break in. It is a triumph of hydraulic engineering. On the sun-baked plains of Africa and Australia, colossal structures rise from the earth, some reaching over 30 feet in height. These are not geological formations, but the cities of one of the world's most successful social insects, the termite. A single mound can house millions of individuals, all working in perfect harmony for the good of the colony. The exterior is a hard, concrete-like shell made from a mixture of soil, saliva, and dung, baked solid by the sun. It provides a formidable defense against the elements and a host of predators, but the true genius of the termite mound lies within. It is a masterpiece of climate control. A complex network of vents and tunnels creates a natural ventilation system, drawing in cool air at the base and expelling warm air at the top. This maintains a remarkably stable temperature and humidity inside, crucial for cultivating the fungus gardens that feed the entire colony. The queen resides deep within a royal chamber, producing thousands of eggs a day, while workers and soldiers tirelessly maintain and defend their towering metropolis. In the grasslands and woodlands of Africa and Asia, a flash of brilliant yellow signals the arrival of a weaver bird. The male, driven by the urgent need to attract a mate, is about to embark on a remarkable feat of craftsmanship. He selects a strong drooping branch, often overhanging water to deter predators, and begins his work. Using his beak and feet with incredible dexterity, he starts by tying a single, long strand of grass or palm leaf into a secure knot, creating the anchor for his entire construction. From this single knot, he meticulously weaves an intricate globe-shaped nest. Strand by strand, he loops and pulls, creating a tightly woven basket that is both durable and waterproof. The nest often features a downward-facing entrance tunnel, making it difficult for snakes and other predators to enter. If a female inspects his work and finds it wanting, she will reject it, and he must tear it down and start all over again. This relentless perfectionism ensures that only the most skilled builders pass on their genes. Beneath the warm, sunlit waters of the tropics lies the largest structure built by any living organism on Earth, the coral reef. It may look like a rocky, underwater mountain range, but it is in fact the collective creation of billions of tiny animals known as coral polyps. Each individual polyp, scarcely bigger than a grain of rice, secretes a hard, calcium carbonate exoskeleton at its base. It lives its entire life fixed in this stony cup, extending its tentacles to feed on passing plankton. As generations of polyps live and die, their exoskeletons build upon one another, layer by stony layer, over thousands of years. This slow, patient accumulation creates the vast, complex structures of the reef. Branching forests, massive walls, and delicate plates. These reefs become vibrant, sprawling cities, providing shelter, food, and breeding grounds for a quarter of all marine species. It is a breathtaking example of how minuscule creatures, working together, can build an entire ecosystem, a living metropolis in the sea. Beneath our very feet, hidden from sight, lies a world of immense complexity and organization. This is the domain of the ant. An ant colony is far more than just a hole in the ground. It is a sprawling subterranean city that can extend many meters deep and cover a vast area. Using their mandibles as tiny shovels, worker ants excavate soil, grain by grain, to construct an intricate network of tunnels and chambers. The design is not random, it is a carefully planned infrastructure. Each chamber has a specific purpose. There are nurseries for the young, larders for storing food, chambers for cultivating fungus, and even refuse pits for waste. The colony has a sophisticated ventilation system to regulate airflow and temperature. Some species even create living structures, linking their bodies together to form temporary bridges or rafts to overcome obstacles or survive floods. The sheer scale and complexity of these underground cities, built by millions of individuals working as one, is a marvel of collective intelligence. The spider is an architect of ethereal beauty and deadly efficiency. Its building material is one of the most remarkable substances in nature, silk. Produced as a liquid in its glands, it is drawn out through spinnerets to become a solid thread, stronger than steel of the same diameter. With this versatile material, the spider constructs its home and its hunting trap in one elegant design, the orb web. The process begins with a single bridge line, cast to the wind to catch on a distant anchor point. Once this foundation is secure, the spider meticulously lays down the radial threads, like the spokes of a wheel, before spiraling outwards to create the sticky capture spiral. The spider knows exactly which threads are sticky and which are safe to walk on. It then waits, often at the center of the web or on a nearby retreat line, feeling for the slightest vibration. The web is not just a passive trap, it is an extension of the spider's own sensory system, a perfectly engineered structure that turns the air itself into a net. Across the Great Plains of North America, the landscape is, dotted with mounds of earth. Now, these aren't just random piles of dirt, but the entrances to the vast underground towns of the prairie dog. These highly social rodents are truly exceptional excavators. You see, a single prairie dog town can cover hundreds of acres and house thousands of individuals in a complex network of interconnected burrows. The entrances are cleverly designed with a rimmed crater to prevent flooding and act as lookout posts. Below ground, the burrow system is, quite frankly, a labyrinth of tunnels leading to specialized chambers. There are sleeping quarters, nurseries for raising pups, and even dedicated latrine areas to maintain hygiene within the community. The burrows have multiple entrances and exits, providing, escape routes from predators like coyotes and badgers. The constant digging and foraging by the prairie dogs also aerates the soil, making them crucial ecosystem engineers that shape the entire prairie habitat for many other species. As spring arrives, so too do the swallows returning from their long migrations. They are master masons, and their chosen building material is mud. The barn swallow, for example, will find a suitable puddle and, with its beak, collect a pellet of mud mixed with its own saliva to make it more adhesive. It then flies to a chosen nesting site, often on a vertical surface under the eaves of a building or a rocky cliff ledge, a place safe from the elements and ground predators. Trip after trip, the bird brings back another pellet of mud, carefully dabbing it into place. It reinforces the structure with bits of grass or straw, much like a human builder uses rebar in concrete. Slowly, a sturdy, cup-shaped nest takes form, a testament to thousands of individual journeys. Once complete, the interior is lined with soft feathers, creating a comfortable and secure cradle for its eggs, and eventually, its chicks. It is a delicate yet remarkably strong piece of pottery, sculpted by a beak. Life for the mole is a life lived in darkness, a solitary existence dedicated to the earth. This creature is a digging machine, perfectly adapted for a subterranean world. Its powerful, spade-like front paws, equipped with heavy claws, can move soil with astonishing efficiency. Its velvety fur can lie in any direction, reducing friction as it moves forwards or backwards through its narrow tunnels. Its eyes are tiny and almost useless, but its sensitive snout and whiskers detect vibrations and scents, mapping out its world. The mole creates a complex network of tunnels that serve different purposes. There are the deep, permanent tunnels that lead to its living chambers and nesting areas, lined with dry grass and leaves for comfort. And then there are the shallow surface tunnels, visible above ground as molehills and ridges. These are its feeding highways. As the mole digs, it searches for its primary food source, earthworms, and other invertebrates that fall into the newly excavated tunnels. Its home is a constantly expanding trapline, a private, dark kingdom of its own making. High in the canopy of the rainforests of Borneo and Sumatra lives one of our closest relatives, the orangutan. This great ape is a creature of the trees, and it is here that it demonstrates its remarkable building skills. Every single evening, without fail, an orangutan builds a new nest to sleep in. This is not a casual affair, it is a carefully considered process. The ape begins by choosing a sturdy fork in a tree, testing the branches for strength and stability, sometimes dozens of feet off the ground. Using its immense strength, it bends and weaves larger branches together to form a solid platform. It then breaks off smaller, leafy branches to create a soft mattress and pillow. The entire construction can take less than 10 minutes. This nightly ritual is crucial for a safe and comfortable rest, protecting it from predators and biting insects. It is a skill learned by young orangutans from watching their mothers, a cultural tradition passed down through generations, and a profound reminder of the intelligence and foresight found within the animal kingdom. From the meticulously woven basket of the weaver bird to the colossal, climate-controlled mounds of the termite, we have witnessed an extraordinary display of ingenuity. These creatures are not following architectural blueprints or using advanced tools. They are guided by instinct, by millions of years of evolutionary refinement that has encoded this incredible knowledge into their very being. Their homes are a perfect expression of their lives, shaped by the unique challenges and opportunities of their environment. They are a solution, born of necessity and crafted with an innate, unthinking genius. The beaver's dam that creates an entire ecosystem, the spider's silken web that is both home and trap, the coral polyp's stony cup that collectively builds a city. Each one is a marvel. These structures remind us that our own drive to build, to create shelter and community, is a deep and ancient impulse that we share with countless other species on this planet. We are but one architect among many, and there is so much we can learn from the quiet, persistent builders of the natural world. So, the next time you walk through a forest, gaze across a field, or even look up at the eaves of a building, take a moment. Look closer. You might just see the handiwork of one of nature's wild architects. By appreciating these small wonders, we deepen our connection to the world around us and foster a greater respect for all the life it holds. The story of creation is not just in our past, it is being written and built every single day, all around us.